Mark Kime here, founder of Disaster Doc, sharing with you now module number 10, Tropical Cyclones. So let's go through those learning objectives together. After completing this lesson, students will be able to list the 3 terms used to describe tropical cyclones, identify the conditions necessary for the formation of a tropical cyclone, describe the Coriolis effect on tropical cyclones, and recognize that tropical cyclone names are identified in advance of each season. We'll also recognize that typhoon severity is categorized into 5 levels. We'll recognize how most deaths occur due to storm surge in a cyclone, and we'll describe how storm surge occurs. We'll identify a hazard map for tropical cyclones, and we'll recognize the major causes of death for tropical cyclones. We'll also list secondary disasters that could result from a tropical cyclone and list the major public health consequences of these storms. We'll also identify measures that can increase the health impact after tropical cyclone disasters and describe how the risk of infectious disease outbreaks after cyclones differs among high and low resource nations. And finally, we'll identify the measures that lessen the health impact of tropical cyclone disasters. So first off, those terms of tropical cyclones, because many of you may have heard of cyclones, you may have heard of hurricanes, you may have heard of typhoons. Those are all 3 the same phenomenon. They're the same storm. And really what makes a difference is where you are in the world. So basically it's just different names for these things according to the local traditions and the local name. So for example, cyclones. We use the word cyclones in the Indian Ocean and Southwest Pacific to describe the exact same storm. We use the word hurricane to describe the same phenomenon in North Atlantic and the Caribbean, the Gulf of Mexico, and also the Eastern Pacific. And then in the Northwestern Pacific, off the coast of Asia, we call them typhoons, which is actually a Chinese word. So there are certain conditions that are necessary for the formation of a tropical cyclone. First off, it's a low pressure weather system that develops over warm water, and that water has to actually be about 80 degrees Fahrenheit. Typically, it occurs between the latitudes of 30 north and 30 south, so it's 30 degrees on either side of the equator. That's when most of these actually develop, and that's why we tend to see them start in those regions and then either spin off to the north or spin off to the south. And these tropical cyclones are rotating winds with a maximum sustained surface wind of more than 73 miles per hour. Now, a couple of things I want to break down there for you. Maximum sustained surface wind. So sustained surface wind, we're basically talking about winds along the surface of the ocean or along the surface of the ground itself, and they're actually sustained. So they're not gusts of 73 miles per hour. These are winds that are sustained at 73 miles per hour. They go from being a storm to actually now at 73 being a cyclone. And finally, there has to be a minimum ocean depth as well. It doesn't occur in very shallow water, so we also have to have this minimum ocean depth. The Coriolis effect is a little different, and we'll talk a little bit about that. I'll take some time to unpack that for you and understand that a little bit better. It causes wind rotation of the storms to be clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. And some of you may already be aware, for example, if you pull the plug on a bathtub and the water goes down the drain, if you're in the northern hemisphere, that water actually goes down the drain in a clockwise fashion. But if you're in the southern hemisphere, for example, down in Australia and other places in Latin America, for example, it actually goes the opposite way. It goes counterclockwise. And that's because of the spin of the earth is being transferred to that water as well. And that's what we would see as the effect of what's called a Coriolis effect. And so that same thing occurs when we're talking about storms as well. So when these storms form on the equator and they tend to then migrate into the northern hemisphere, those storms, the wind rotation of those storms actually goes clockwise. If we're looking at the same phenomenon, only it goes to the southern hemisphere, then we see a counterclockwise spin to those storms. So it's just a minor detail, but it is interesting to be able to notice and why those storms tend to go in one direction or the other based upon this Coriolis effect. So we're all aware, of course, that many times the tropical cyclones have a name, and they actually use these names to reduce confusion when more than one storm is present at the same time. So you can imagine if we were using numbers or letters to describe these and trying to keep those straight, but giving them names is sort of like trying to keep people names straight in a group as well. So most naming systems actually use first names when we're talking about in Western nations. So that naming system in the Western Pacific, however, tends to use animals and flowers and astrological signs, and in some cases actually personal names. Now I want to talk about the progression of tropical storms because we start off with a storm, what's called a depression, then we have a storm, and then we have a tropical cyclone. So tropical depressions are actually storms that actually have winds of less than 38 miles per hour. So they call those a tropical depression to be able to separate those from what are tropical storms. Tropical storms are the same kind of phenomenon, only stronger, and the wind speeds are about 39 to 73 miles per hour. Once the same storm gets up to 74 miles per hour and becomes more densely compact and stronger winds and so on, then we call those tropical cyclones. So 74 miles per hour and greater are when the tropical cyclone threshold begins. And we also use this scale that's called the Saffir-Simpson scale for hurricane intensity. So right at 74 miles per hour, the storm is actually called a Category 1, and that runs from the wind speeds of 74 miles per hour to 95 miles per hour. In most cases, those are associated with a storm surge of about 4 to 5 feet, the storm surge that comes in to land when the tropical cyclone hits land. And in the most cases with 74 to 95 miles per hour, there's minimal damage. Many times it's the foliage damage, so we see leaves coming off the trees and so on, so mostly minor damage. In a Category 2, with 96 to 110 miles per hour, storm surge a little higher, 6 to 8 feet waves coming in on the shoreline, and moderate amount of damage, roofing and windows. So the way that I remember it is actually at about a Category 2 at 100 miles per hour winds is when we normally would first start seeing the shingles coming off of roofs. So if you have a shingle roof, we can expect to have that kind of damage. We see some windows breaking in that period of time. We don't see extensive damage, but there is starting to be structural damage to homes and property. At Category 3, 111 miles per hour to 130 miles per hour, we then start seeing pretty significant storm surge, 9 to 12 feet. So we are starting to see now waves coming in the shore that are pretty significant. Potential for flooding now starts to exist when we're looking at those Category 3. And as a matter of fact, Hurricane Katrina was a Category 3, caused extensive flooding because of the structural failure of the levees there. The damage is also rather extensive, and so we can expect to see structural damage when we're talking about these Category 3 storms. You can also see trees coming down, limbs coming down, power lines snapping, and structural damage to homes as well, especially when we're looking at the roofs for these Category 3. So these start to become pretty serious storms at that level. Category 4 storms actually have 131 to 155 miles per hour winds. The storm surge now is getting pretty serious, 13 to 18 foot waves coming in. You have the even more so, you see this rise, especially if it's coming in at high tide. You can see significant flooding with these Category 4 storms. There's also extensive damage. The storm surge is really what we have to start worrying about there when we're talking about Category 4. Could be big, large areas that are being flooded as well. And then finally, a Category 5 storm, we're looking at very significant wind speeds, greater than 155 miles per hour and greater than an 18-foot storm surge. So we're really talking about catastrophic level damage, structural failures, significant storm surge, long-range flooding. We're really talking about a very serious storm. And some of those wind speeds are actually higher than 155 miles per hour, so we really see what are called the super typhoons, and we've been seeing those in the past. For example, Typhoon Haiyan was considered to be a super typhoon when it hit the Philippines over the past couple of years. So I mentioned that idea of storm surge, and I want to talk more about that because it's really important to recognize the effects of storm surge. Storm surge is actually one of the #1 killers when we're looking at what are the causes of death related to these tropical cyclones. And actually, as I've said before, people die from the water, not necessarily dying from the wind in these types of storms. So storm surge is what brings in that water. So what happens is as the wind rotates in this particular storm, water is pulled into the spiral of the storm. And that water piles up and is pushed onto land by the storm, causing flooding. So as that storm is moving towards the land, it's pushing a wall of water ahead of it. And when that storm breaks land, so does that storm surge as well. And the flooding is more severe on shallow water coastlines. So once again, these places where people really love to have beaches, nice shallow beach that people can play in and live and fish and so on, these are areas that can also be very, very much devastated by these particular types of storm surges. And we can also see wind, waves, and sea level rise all contribute to storm surge. And as well, if a storm surge occurs at the same time as a high tide, then now it's even magnified even more. So we have these various factors that can make a storm surge be much more severe, much more deadly. I want to share with you this hazard map in particular, and by now you should be recognizing some of this hazard mapping that we've done in this particular seminar. And the United Nations does a great job of providing these hazard maps for various parts around the world. And this is one of them, actually looking at tropical storm risk in the Asia-Pacific region. So you can see Asia over the side and many of the Pacific Islands. And the very dark areas here, the very, very dark blue, are the areas where the storms are most commonly occur, and also the most severe storms as well. So we can use this historical data of where storms have occurred in the past to then predict where storms may occur in the future. Now, we've talked about a little bit about this idea of tropical cyclones and what the causes of death are, and I want to review that with you again now that we've talked a little bit more about the storm surge itself. So, number one cause of death related to a tropical cyclone is drowning. And we know that that drowning now comes from not only the storm surge, but also the heavy rains that come into the coastline, and many of the fresh water, the rivers and so on, tend to flood in these areas as well. Those can also cause drowning. We also see this second wave of deaths that occur due to traumatic injury, and actually it's kind of odd that the most of these traumatic injuries actually occur during the recovery phase, during cleanup. And once again, this is when people are out, they're up on top of their roofs trying to repair roofs, they're cutting down trees, they may be moving power lines, they may be using materials and tools that they haven't used before, for example, like ladders, or using chainsaws for the first time, or using gasoline or other type of fuel stoves that they're not used to, and then they become injured during this cleanup or recovery phase. So is that preventable? Absolutely. And that's why we're here. We want to point out these things that we can actually prevent. And the same thing as well with drowning as well, right? Can't we prevent people from drowning in a tropical cyclone? Of course we can. We do so by evacuating people from that area, getting them out of where the storm surge can occur, getting them out of those floodplains where the rivers are, and then really being able to protect them. So that way we do so in advance of the storm rather than waiting for these things to occur. The same thing with these traumatic injuries that occur when we're talking about rehabilitation, recovery efforts, and so on that are occurring in the neighborhoods. By getting the information out, helping people to protect themselves, to be safe, giving them good advice on how to best be able to manage these tools, how to best be able to protect themselves against these additional injuries, we should be able to lower the causes of death, the numbers of death associated with these tropical cyclones. So let's look in general terms now at the public health consequences of tropical cyclones. We've talked about in particular about the deaths themselves, but there are other factors that also complicate things when we're talking about its influence on your health, right? So one of the things we know, of course, is that there's a large number of deaths in the developing world, the low resource nations compared to high resource nations. And I want to talk about that because that's an important point. So why do you think that is, that we have more deaths in low resource nations compared to high resource nations? Well, the answer is actually that high resource nations have better monitoring, they have better forecasting to be able to tell exactly where the storm will hit, and then they have a better warning system and also better evacuation systems where people can actually take advantage of evacuation measures and get out of the way of these storm surges and this flooding that occurs in the rivers. So it's this idea of early warning that really makes a difference between one nation and another nation. So once again, we have a long way to go, but we've made some good accomplishments in being able to lower those death rates for some of the countries of the world. And I want to encourage you to join me in that process, to be able to lower this. This is something, needless deaths, you and I can make a difference in this, and I want you to help me because I know by far you're going to do much more than I ever could as one man. So this other phenomenon as well that we see with this particular set of storms is that we actually see a lot of displacement, right? People lose their homes either due to flooding or due to wind damage or due to loss of water and electricity and so on. And so people are displaced as a result of these tropical cyclones. And so the majority of the other things that you see in this particular figure of being orange or amber are actually a result of people that lose their homes. And then once again, the public concern for safety, because these are relatively unusual events in people's lives, and this is a big dramatic type of a storm. People's concern for safety is actually very high with these as well. So we have to recognize once again the ability to be able to give people the information that they need so that they have a good situational awareness of what's going on, what's already happened, and then also good lessons and good advice on how to protect themselves and protect their families, protect their livelihood. So let's compare the health effects of tropical cyclones to other natural disasters. I'm going to give you some statistics that have been collected over the past 50 years. And one of the things that we want to recognize is that the second most frequent natural disaster during the past 50 years is actually tropical cyclones. And these tropical cyclones comprise 3 of the top 10 deadliest natural disasters during the past 50 years. So these can be actually very large events and very deadly events as well. And the world's 10 deadliest tropical cyclones over the past 115, 116 years, Bangladesh, number 1, 300,000 people killed in 1970. Once again, we've mentioned this as well, the low-lying delta area, tropical cyclone comes into that area, lots of flooding and a low amount of warning as well. You can see number 2 in this particular table, 1991, 138,000 people, almost 139,000 people, once again in Bangladesh. We skip down below, you see Bangladesh again and again and again and again. So that actually, out of the top 10, all six of these top 10 deadliest tropical cyclones actually occurred in Bangladesh. So let's unpack that a little bit and talk about that also in relation to the other types of, the other locations of these disasters in Myanmar and in China and so on. What makes these particular phenomena so dangerous? First off, delta. River delta area. Usually when a river comes down to a delta, it actually large river and then splits off into many tributaries as it gets to the delta. So it makes that characteristic triangle or the delta symbol, right? And that delta actually forms right at the coastline. Usually the coastline goes into the ocean itself, and that's where these tropical cyclones occur. So the tropical cyclone comes, runs into the delta, and does several things. One of them is it pushes the storm surge into those rivers of the delta, so creates high level cresting in the rivers themselves. So the storm surge contributing, also heavy rains coming down to those rivers as well, cause them to swell. And then the fact that these are tributaries, so they split, and the people living in between the various rivers actually now have water coming from one side and water coming from the other. And it creates this floodplain that could actually extend for many, many miles. So it's very difficult to evacuate just a few miles to get out of the way. Many times you may have to go actually tens of miles or hundreds of miles to be able to get away from that flood. And that's the bad combination when we're talking about Bangladesh. But in particular, there's another complicating factor as well, another contributing factor that also causes these large amounts of death. It's the socioeconomic status and the resources that are available in that particular country. So resources for forecasting, for monitoring the hazard, for providing early warning to the population. And then once the population is warned, the resources that that population then has in order to be able to evacuate. So people have to have the resources available, either means of transportation, funding to be able to do so, and be able to hire those kinds of things as well. So that combination actually is what really causes these most deadliest tropical cyclones in the world, whether this is in Bangladesh, whether it's in Myanmar or other areas. We also see secondary disasters that are caused by tropical cyclones, and I've mentioned that inland flooding. And that can also include flash floods, which we know by now flash floods are the most dangerous type of floods comparatively. We also see landslides and mudslides as well with these tropical cyclones, because heavy rains coming down on hillsides loosen that soil and cause slope failures to occur and debris flows also to occur as well. We also see tornadoes actually inside and spinning off of these hurricanes or these tropical cyclones, smaller storms called tornadoes. And we're going to talk more about tornadoes in particular later in this seminar. But one of the things we have to recognize is actually there can be tornadoes inside and created by tropical cyclones. So it's sort of a double whammy, isn't it? And then the other aspect that I really want you to remember, of course, is storm surge. We have to protect people against that, which is one of the most deadly consequences of these secondary disasters. So there are measures that increase the health impact of these cyclone disasters. These include human factors as well as natural factors. And some of those human factors include poor building design and construction. They also include flying debris or structural collapse from different materials that may be at that coastline. They include poor coastal land use patterns where we put critical infrastructure too close to where the storm surge or wind damage may occur. There's also aspects of lack of early warning that we talked about, and also lack of evacuation, which is really important when we're talking about saving people's lives. There's also a lack of resilient source of potable water. So water treatment facilities that are too close to the coastline, too close to where the storm surge can occur, then knock out the potable water systems for those communities. And so that's always another threat to the health of that particular population. There are other measures that increase the health impact of cyclone disasters, and one of them, the cause of death and extent of mortality, differs among high-resource and low-resource nations. Before 1900, the majority of U.S. deaths occurred during the impact phase. That's when the wind was actually blowing, when the tropical cyclone was breaking ground, hitting those affected communities, and drowning at that point in time due to storm surge was the #1 cause of death. However, that changed after 1990 in the United States. The majority of deaths now occur in the recovery phase and are due to cleanup injuries. Why do you think that is? Of course, it's early warning and evacuation. That's what made the difference. Forecasting in the United States after 1990 improved remarkably. The early warning systems improved as well with advances in technology and communication capabilities. And in addition as well, the policies that involved evacuation of these populations into safe areas. So out of harm's way, people much safer. And now we see those recovery phase type of cleanup injuries. Electrocutions from down power lines occur, blunt trauma from falling trees, motor vehicle accidents as well when people are driving unsafe under unsafe conditions, as well as also falls from roofs and other from trees and so on. So we really have to be careful when we're talking about recovery phase in these high resource nations. We can take these additional measures that lessen the health impact of these cyclone disasters. And one of them, the main one that I want to get across, if you get nothing else out of this seminar, I want you to reduce your exposure. That's so important. That's what saves your life. It saves the suffering. It saves the losses that we can never get back. So reducing the exposure is really important. And we start right off again with what? It's that hazard map, isn't it, right? We look at the location of the hazard map and we say, are we in this high-risk area? And then we monitor those hazards. So we monitor the cyclones, where they occur at sea, are they heading our way? So that's first, we should always be thinking in terms of keeping in touch with the weather systems and the weather forecasting as well. And then this early warning system. It can be through modern technology like sirens and smartphones and internet and television and radio and so on. But the importance of that to get that message out to the populations. And then the third thing as well, safe evacuations and sheltering process. And it's easier said than done. You know, to get the warning out to people is one thing. To get them to be able to evacuate in a safe way, far enough ahead of the disaster occurrence itself so that people have plenty of time to be able to get out, do so safely without rushing and having other kinds of complications. And then sheltering people in conditions that are actually also promote good health. We pack people into small areas, not give them the adequate food, water, shelter, security that they need in these particular areas. Now we're taking one disaster and turning it into another. We also want to be able to provide good risk communication. So what is that? That's communicating things that are risky to the public so that they can protect themselves, telling them what's safe and what's not safe, and encourage them to use these safe practices in order to be able to provide better protection for themselves during that cleanup phase when we know people are at higher risk. The other thing as well are building codes, building houses that actually withstand these tropical cyclone winds. And it's actually, you know, sort of simple to think about, but many times we ignore those kinds of opportunities to be able to build things safer. For example, in the Western societies, many of the homes here in the United States, of course, have these sort of slanted roofs. And you have a slope on the roof itself, and then you have a wall that comes up underneath that as well, right? And there's a little overhang here that occurs with that particular roof, where there's a little eave, so to speak, that against the wall itself. And when the wind blows, it actually hits that wall and turns and goes up underneath that roof itself, right? And so by the way that we build these homes, the wind has no place to go. It can either go down to the ground or up underneath that roof. And the constant wind, when it gets high enough, actually peels that roof off. So the very way that we construct our homes, the very slanted roofs, without connecting those together in a way that will resist that wind velocity, we actually create homes that are more likely to be able to lose their roofs. And when they lose their roof, once again, you've lost your shelter, you're now displaced, and you're now facing things, other issues that could be potential health threats of food, water, sanitation, solid waste management, all the other kinds of things that then place you in a secondary aspect of danger or health threat. We also want to apply injury prevention and control measures for worker safety as well as just the average people that are doing their cleanup. We want to teach people how to use generators effectively, chainsaws, other types of devices that people may not necessarily be aware, may not have a lot of experience in using. We want to make sure that people have good information in order to protect themselves during that cleanup phase. And in addition to reducing this exposure, we also, of course, want to reduce vulnerability. And I've said this before, this is my favorite part, right? It's these ideas of reducing vulnerability that healthy people are less likely to die in a disaster. So health promotion, lessening health disparities among different populations and different ethnicities and groups that are within the population itself. We want to lessen the dependence upon daily medication or daily therapies. And so if you don't ever get it, diabetes, have a healthy lifestyle, healthy food, good exercise, and so on, we prevent you from getting diabetes. Now you're not dependent upon insulin during these particular storms. And when you lose your electricity, of course, insulin needs to be refrigerated. So you're not in that complicated mixture of requiring daily medication that's difficult to provide. So once again, thinking far ahead in terms of these elements that reduce vulnerability. We want to improve personal mobility, and there are a lot of measures that are doing that nowadays where people's mobility is extended way into the later years of life, and we want to continue to do that because, once again, people that are mobile can evacuate much easier. People that are able to communicate and have the support of the community and this public knowledge and awareness and this cohesiveness, all of this goes together for good evacuations and healthful outcomes. And we also want to reduce the burden of injury and chronic disease. Once again, these are deleterious for people's ability to once again be able to communicate, to be mobile, to do the kinds of things that are necessary in order to not only evacuate, but also come back and settle back into a good and long-term recovery. And finally, we talked about exposures, reducing vulnerabilities. The third thing, of course, what is it? Building capacity, right? We want to build capacity to be resilient. Better public education, better socioeconomic status, better access to health care, that just makes healthy people. Healthy people are resilient, right? And healthy buildings also resilient. We want to promote structural and non-structural mitigation so that these buildings are resistant to storms, resistant to floods, resistant to high winds, and so on. And in addition, healthy communities. We want to make sure that our hospitals are resistant as well. They're resilient. And there's this model as well that's doing so well actually in other areas in Central America and South America. Mexico in particular does a great job with this. The Safe Hospital Initiative. I want to share this with you. So the idea is that we want our hospitals to survive the disasters because those people that do get injured during these disasters, they need hospital care, right? So the idea, of course, is to spend a little extra time making sure that that hospital has all the measures that it needs in order to stay functional. And it's not necessarily damage to the structure of the hospital that knocks these hospitals out of commission from time to time. Sometimes it can be the water system or the power generation or other types of aspects of ability to be able to get the human resources, the workers and the doctors and nurses and so on there to the hospital. So Safe Hospitals is a system-wide approach, and there's been much success in many areas of the world, especially in Mexico now, where this is becoming actually public law. And we're seeing that extension of safe hospital programs into schools, clinics, and other buildings as well. So this idea of building buildings that are actually safer and more resilient, once again, it's cost effective and actually it's much more humane, is it not? So the other aspect as well, building resilient public services, resilient water systems, resilient power systems, and so on. Some areas actually gave up the idea of putting overhead power lines, running them on the posts, and then every single tropical cyclone that comes through knocks down the power poles, and they spend weeks and weeks trying to put the power back up on the lines again, only to have it knocked down again 3 years later. Some countries, some communities have actually buried those lines so that they're done with that particular aspect. And once again, the public service is resilient. And then finally, I love this one, to promote social cohesion and inclusiveness, because when we all work together, first off, it's just the right thing to do, isn't it? But the second thing as well is it's much more effective when we all work together in order to make these things safer, these areas safer, our communities safer, our hospitals, our buildings, our families, our neighborhoods, all of us work together in that aspect. And the value is not only at the time of the disaster, but the value is every day. Even if a disaster doesn't occur, you're just in a better place to live.